Welcome to MRS Bulletin's Materials News podcast, providing breakthrough news and interviews with researchers on hot topics in materials research. My name is Laura Lay. If you've been paying attention to the energy industry and global sustainability goals, you'll know that there's a race to develop alternative means of powering transportation. Electric vehicles are rising in popularity, but one challenge for this technology is heavy batteries with limited capacity. New research has made a vital step towards batteries with an improved energy density. Whereas batteries that are currently in widespread use are made with an excess of lithium, these batteries would have zero excess lithium, and to do it, they use a nanotwinned copper foil, which so far has only been looked at for other applications.
I think we've been the first to investigate this for battery applications.
That was Dominik Bresser from the Helmholtz Institute Ulm and the Karlsruhe Institute of Technology in Germany. In existing lithium-ion battery technology, the positive electrode is made from lithium and some transition metal oxide. Lithium is intercalated into the graphite structure, which forms a negative electrode and sits on top of a current collector. In a zero-excess battery, graphite is not required. Instead, metallic lithium is coated directly onto the current collector.
The idea here is that theoretically, you don't have any lithium metal at the negative electrode to start with, so no reservoir, no excess. And at the same time, you also don't have graphite. So you really you take the lithium from the cathode side and you plate it as metallic lithium at the negative electrode. Your battery cell really contains only the amount of lithium that you would really ideally need.
At the negative electrode, the current collector is made of copper foil. Dominik's team used a nanotwinned copper foil, which has an essentially pure single orientation and dense twin boundaries. They found that lithium deposits more densely and much more homogeneously on this nanotwinned copper foil than on commercial foils.
Seeing then how much more homogeneous the lithium deposit was on the nanotwinned copper foil compared to the conventional copper foil, this was a little surprising. So the extent of improvement was more than I was expecting. The denser structures means less surface area. And less surface area or less surface means less reaction with the electrolyte.
This increases the reversibility of the lithium plating process, which means that the battery was stable after multiple charge cycles. The zero excess lithium metal plated onto the nanotwinned copper foil also suppressed dendrite formation. In older lithium metal batteries, dendritic structures of metallic lithium can grow large enough to bridge between the positive and negative electrodes, forming a short circuit which leads to high temperatures and the possibility of a fire or explosion. So given that the nanotwinned copper foil avoids this potentially dangerous scenario, it could solve many challenges. It's also a novel approach.
This nanotwinned copper foil, we consider this important because usually people have only looked so far at optimized electrolyte compositions for zero-excess lithium metal batteries, or they have looked at specific functional layers on top of the copper electrode. But nobody has looked at the electrode, at the copper foil, at the substrate as such.
Dominik is keen to stress that the work of his team is not a magic bullet and there is still more work to do.
Our work might contribute, but it does not solve certainly all the challenges related to this concept.
This work was published in a recent issue of ACS Applied Energy Materials. My name is Laura Lay from the Materials Research Society. For more news, log on to the MRS Bulletin website at mrsbulletin.org. Follow us on Twitter at MRS Bulletin. Don't miss the next episode of MRS Bulletin Materials News. Subscribe now. Thank you for listening.